So you don't have to have like all of this memorized. You just need to know like linear means line. You need to know the shape of an absolute value graph, etc. Okay. As for the increasing, decreasing, that's kind of helping us with what the quiz is on this week. So we're going to take some notes on all of these parent functions, and then we'll look at what the Delta Math assignment is. So eventually your learning targets for this will be to describe the transformations that change a graph from a parent function into a new equation, and do some matching of transformed equations to their graphs. And today, all you're going to need to do is identify the parent function, okay? We're not going to do all the rest of this stuff quite yet. So these are all linear functions. There's what's called a constant function, which would just be a horizontal line. The identity function, where y equals x, or what we generally think of as a linear function, okay? So we're going to call this, generally we write, I would say either one of these, y equals x or y equals mx plus b could go up there as the parent function. What is the domain and range for this, guys? Yeah, all real numbers for both. You could write the funny R if you wanted. If it is the parent function being just this line y equals x, the x-intercept would be at 0, 0, and the y-intercept would also be at 0, 0. It has no maxes or mins. And the parent function itself, what is it doing the whole time here? Increasing. What would make it decreasing? Say again, Jada? Yes. Can you please pull your mask up? So if we had a negative slope, then it would be decreasing. Perfect. End behavior, the way it's drawn, how do we write that? Okay. So not necessarily the order I would have said it, but that's all good. Y is going up as x goes to the right, okay? And y is going down as x goes to the left. And we can write those with f of x notation. We can write them with I just would have probably started with the left instead of the right. But yeah, as far as the y's first, x's first, doesn't matter. Discontinuities, it has none. Okay, it is a continuous graph. Even or odd function, is this an even or odd function? The way it's drawn, the plain old parent function is an odd function, right? You could turn that 180, it would be the same. Now, as soon as we start doing any transformations to it, then it will not probably be an odd function anymore. Okay. The next one we're going to talk about is the absolute value function. Eventually, we'll spend a lot of time talking about what this does, and this does, and this does. But this is just the parent function. So the parent function is y equals absolute value of x. Domain, left to right, guys? Yeah, all real numbers. But the range, what can come out of an absolute value? Only what kind of numbers? Yep, so 0 and up. It has an x-intercept and a y-intercept at 0, 0. It has an absolute min at 0, 0. Where's it increasing? Can anybody tell me which piece of it is increasing? Yes, this right-hand side, okay? So the right-hand side is increasing and the left-hand side is decreasing. Remember how that goes? Left to right. And both ends are going up, yes? So maybe I'll use f of x this time, is going up as x goes left, and it's going up as x goes right. That's supposed to be an infinity, the tiniest little infinity at the end there, sorry. Any discontinuities? Nope. Even, odd, neither. Any symmetry there, guys? Yeah, it has y-axis symmetry, right? So it is an even function. All right, how many of you are pretty comfortable knowing that the absolute value function was a V shape? Did you know that one ahead of time? Okay, next one should be equally, we've talked a lot about this one already. Well, this slide talks about the polynomial being any power, and we're going to talk about what this does. It stretches and reflects, this shifts left and right, and this shifts up and down, okay? And when it's an even, when the n is an even degree, both ends will go up. It's odd, one end, left end will go down, but we're gonna do it separately here. So this is a y equals x squared, or quadratic. Okay, the name is out here, quadratic. You can put anything into a quadratic, but after you square it, it will only come out as a positive number. X and y intercepts would be at 0, 0. And it has, in its current form, an absolute min at 0, 0. Just like the absolute value graph, it is increasing on the right, okay, and decreasing on the left. And both ends are going up. Maybe I'll start with the x's this time, just to give you all the different varieties. As I go to the left, y is going up. As I go to the right, y is going up. Lots of ways you can write end behavior. It has no discontinuities. Even, odd, or neither, guys. It is even. It has y-axis symmetry. Everybody okay? All right, then we have the cubic, which is y equals x to the third. The domain is still all real numbers for both domain and range. I'll write it that way this time. Okay, all real numbers, it does get wider and wider and go up and down forever. The x and y intercept is still 0, 0. Does it have any maxes or mins? No, it has an inflection point, but it has no maxes and mins. What about increasing, guys? If I start on the left, what happens? It's all increasing, okay? It is all increasing. Now the end behavior, this is an odd power or degree. So as we go left, it is also the y values are getting more and more negative. And as we go right, the y values are getting larger and larger. So it's down on the left, up on the right. It has no discontinuities. What about symmetry? Yep, it has origin symmetry, so it's odd. All right, I'm hoping these are all very familiar so far. Everybody okay? Then we're going to talk about radical functions, both the square root and the cube root. Okay. Now, this says where n is positive and even, so this would be like a square root or a fourth root or a sixth root will be this shape. If you have a third root, these are the only two parent functions we're really going to talk about, a square root and cubed root, but if you had a fifth root or a seventh root, it would also have negatives, so it would look like this. And then eventually we'll talk about all the transformations you can do with those things. So this would just be y equals square root of x. So what can you put into a square root? We've been working on this for a while. What can you put into a square root? Only what? Only positive numbers. So you could say x has to be greater than or equal to 0, or in interval notation there, and what comes out will also be positive numbers. Up to and including 0. So it's really not positive numbers, it's non-negative. Good answer. I like that description. Okay. It does actually touch at 0, 0. If you put in a 0, you'll get out a 0. Oops, sorry. I didn't mean to move that. It has a min at 0, 0, according to the definition that it will never go any lower than that. I would not ask you that. But what about increasing and decreasing, guys? As you go left to right, what is this doing? It is increasing, and it's increasing from 0 to the right because it doesn't have any values to the left of 0. End behavior is a little funky here because you can't say as it goes to negative infinity, it doesn't. You would actually say the y is going towards infinity as x goes to the right. But then you would say as y gets closer to 0 as x gets closer to 0. That's the best you could do for the left side. I will not ask you that. All right. It has no discontinuities, meaning jumps. It definitely has places where it's not defined, but it doesn't have any jumps or infinite discontinuities, which would be a asymptote, and it does not have any, what else am I missing? Holes, yeah, point discontinuities. Even, odd, or neither. Yep, nothing here. All right, so this is a cubed root of x. And you can actually, like, if you take the cubed root of -1, you get out -1. So it will have values in both the first and third quadrants. The domain is all real numbers. The range is all real numbers. It goes through 0, 0. It has no maxes or mins. And what do you think about increasing, decreasing? Yes, it is increasing the whole time. Whoops. Yes, that's what I meant to write. It is very, very slow, but on the left, it is going down ever so slightly. So if I did X first, say it's going down, and on the right, it is going up ever so slowly. It has no discontinuities. Even, odd, or neither, guys. Yep, this has origin symmetry. All right, now there's a few we're not going to spend a ton of time on in terms of transformations in class, because it will have its own. Okay, rational functions is going to be a whole separate unit or separate couple days. I mean, we will not do a lot of these in terms of simple transformations, but it is y equals 1 over x would be the parent. It's called the reciprocal function. It's also called a rational function whenever x is in the denominator. What is the one number you cannot divide by? 0. So it's all real numbers, but x cannot equal 0. And the same is true for the range, everything except 0. So if you were writing that in interval notation, it would have looked like this. But that's a lot of hooey. Okay, so it has no x or y intercepts. It never touches either axis. It has no extrema. It is actually always decreasing from -infinity to 0, and then again from 0 to infinity. And again, that's just because it has no, that's the domain. Remember, the intervals are domain intervals, and since it has no value at 0, you have to state it in two pieces. As you go further to the left, what is this approaching, guys? As I get closer and further to the left, it is approaching 0. And the same thing is happening on the right as I go further and further to the right. That's supposed to be an X, sorry, that's funky. The Y value is also getting closer and closer to 0. It does have a discontinuity. It has a line or an asymptote at x equals 0. They usually only want the x value discontinuity, and it is odd. We will not spend a lot of time on that one until we do a whole separate couple days on rational functions and reciprocal functions. All right, an exponential function. We will also have a whole chapter on exponents and logs. But exponential growth and exponential decay are different than logarithmic in that they both have a vertical asymptote. I'm sorry, that's a horizontal asymptote. Let me try that again. Okay, they will have a horizontal asymptote here. So this is y equals, and they either write it as b to the x or e to the x. This is exponential, and this is like the inverse of a common log. Natural log, not common log. Sorry. And the domain is still all real numbers. The range is 0 and up. It cannot actually hit 0. Therefore, it has no x-intercept. What power, guys, would make any number? I don't know that you're going to know the answer to that, but any number to the 0 power is 1. Does that sound okay? So any number to the 0 power is 1. So therefore, when you make x a 0, you would always get out a 1. So any number to the 0 power is 1. I did not phrase that well. I apologize. It has no extrema. It is all increasing from negative infinity to infinity. It would be decreasing if b was less than 1. So if you had we will eventually talk about things like this. Okay, when b is less than 1, then it is all decreasing because it's called exponential decay. That's all I'm going to write there for that. The one that we have sketched here on the far left is approaching 0, and on the far right is approaching infinity. That would change if it was exponential decay. Left to right, it has no x discontinuities, and it is not even or odd. All right, couple more. Logarithmic graphs have vertical asymptotes, okay? Because you cannot take the log of a negative number. They are the inverses of exponential graphs. So we could write the natural log or the common log, which would be log base 10. Either one of those would have the same graph. These are the inverse of what we just did, okay? So where on those the range was 0 and greater, on these the domain is 0 and greater, and the range is all real numbers. You're just flipping what was happening on the exponential graph. So that one had no x-intercept. It had no, yes, it had a y-intercept. This one has an x-intercept. The way this is drawn, it is always increasing. The domain interval would be from 0 to the right. The end behavior would say as x gets close to 0, the y is going down. As x goes off to the right, the y is getting bigger. Not going to ask you that. It's not said to have a discontinuity, even though it's not defined over here. And it's neither. All right. One that we do need to mess around a little bit with, like I said, exponentials and logs will have their own chapter or unit. But the greatest integer function is when we're going to do, what else is this called? Does anybody know from looking at the picture? Yep, this is called the step function. Okay. But it's actually called the greatest integer function, or it's called the round down function. Because the rule is it is the greatest integer less than or equal to a number. So you round down or to the left. Now, this is on our calculator. It is under the math. Okay, I don't know if you want to write this somewhere, but math. If you arrow to the right, there is a menu called numbers, and it is the number 5 is the integer function. Absolute value is number 1. Okay, number 1 is absolute value, if you ever need that. And number 5 is the greatest integer function. All right. We're not going to get too carried away with all the complexities of this. The domain is all real numbers. Oh, I'm sorry. Yes, thank you. It depends how some books will write it with a double absolute value, and some use a more like this, like a parenthesis with a double. Okay, either one of those notations is the greatest integer, or some will, like your calculator would just say int for greatest integer. Good question. Thanks. Okay. And it is also just called the step function. The domain is all real numbers. The output will only be integers. And I'm going to go with, we don't care about any of the rest of this stuff for this. Let's talk, though, about what the greatest integer function does. If you put in, I'll use the double absolute values. If you put in 1.5, you round down to the greatest integer less than or equal to that. So it would round down to a 1, okay? Be very careful, though, on the negative side. What is the next number less than or equal to negative 2.1? Okay. What about negative 2.9? It's rounding always to the left. So negative 2.1 stays at negative 2, but so does negative. Why is this making me crazy? Yes. No. You have to round to the left. So this would round to negative 3. The last negative 2.1 rounds down to negative 3. This rounds down to negative 3. This rounds down to 1. It's got to round to the left. On the number line, if you were at negative 2, negative 3, if you're here at negative 2.1, you have to round to negative 3. Does that help? I'm making this difficult. 3.7 would still round down to 3, okay? Just watch the negatives. It gets messy, and I'm not helping today. All right. Sine and cosine parent functions. We're going to put them in as two different things, but when we start doing transformations, we will learn that they're very similar. If you are taking trig right now, have you done any graphing yet? No? Okay. If you took Honors Algebra 2, you may have seen these before a little bit. Okay. So quickly, y equals sine of x. It goes through the origin and is an odd function. Okay, the domain is all real numbers, but the range is it can only go from -1 to 1. It will cross the x-axis starting at 0, and then every time you add another pi. So pi, 2 pi, 3 pi, we usually write that as pi n, where n is any integer. You could put in 6 pi's and it would be crossing at an x-intercept. The only y-intercept is at 0, 0. And I'm not going to worry about anything else. If it is a cosine graph, the domain is still all real numbers. The range is still -1 to 1, but this time it has y-axis symmetry, so it is an even function. It would have intercepts. This would be halfway to pi, which would be pi over 2. And then you would add pi to find the next one. And it crosses the y-intercept, it crosses the y-axis at 1. I'm never going to ask you that until we've actually done the trig unit. I'm not going to ask you anything about sine and cosine. It is possible it would come up in delta math that it has, I'll show you, but it's just really quick. It'll flash you a graph and say, what's the parent function? All right, I think that's it. So we're going to eventually do all this kind of stuff, talk about the attributes of the function, what these transformations do, where they shift them up, down, left, right, whether they stretch them, okay? So in delta math, there's a short assignment, but you also need to be sure you look over the quiz review so you know what you need me to go over. I don't know. I don't know what this is. I think I was in the middle of setting up an assignment. I'm just going to pick something and edit it later. I need to remember that I need to edit it later. what I wanted to show you was what the assignment looks like. The assignment, okay, the first part of the assignment is a timed thing, and I really don't care how fast you go. But does anybody know which of those would be the right one for that function? Just y equals x. Is that a cosine or sine? Did anybody catch that? Yeah, it has symmetry with the y, so this is still cosine. Anybody know which one that is? 1 over x. So you're welcome to use your notes, and I'm really not that worried about how fast you go on these, okay? And then you just push stop. It wants you to get 10 in 300 seconds or something. I set it very low, okay. Then identify the function type given the graph. Anybody know which that one would be? I know it's shifted, but what is that? That's a cubic, okay. What am I looking at? Oh, next problem. So this is, anybody get that one? You can look at your notes, but it is an exponential. You might notice if you look down there what the choices were, that would help too. All right, then there's a couple discovery activities where it wants you to try to figure out how to move the graph to there. And so we have not talked about this yet, so you're just going to have to play around with it, okay? I made them very basic, I think, where you only have to do, you don't have to do any stretches or anything, okay? See, did the plus one move it in the right direction to get to the red one? No, so you would need to, I do need to put a 3 back there. My mouse is not, okay. So I need to make that a -1. And then it moves. So when you get it there, it says now you can press submit, okay? So there's just a couple of those where you have to fiddle around with it and try to get it to work. Like this one's a parabola. Anybody know what's going to flip it over? You guys should be good at this. We've already done parabolas, but you would need a negative out front, okay? And then it looks like the vertex is 4, -2. So remember that's opposite of h. And okay, so once you get it there, then you just hit submit. All right, there's just like 3 of those. One is an absolute value, I think. Any questions about the delta math?